Welcome guys to today's class. In today's video, we want to discuss how to conduct experiments on electricity. Yes, this is another interesting part of physics practical, very sweet. Experiment on electricity. And so, do well to what? Pay attention so that you have a lot to learn. We want to see how to conduct these experiments without touching apparatus. Remember, that is more of the reason why I've been doing a lot of videos you have on my channel, so that to see how you can learn ways you can conduct your experiments without touching apparatus. Okay, now the aim of today's experiment is to determine the variation of resistance with distance along a given what? Wire. So we'll be looking at what is the relationship between resistance and distance of a given wire. Yes, whether they are directly related or inversely related, or no relationship exists. Let's check. Apparatus: length of resistance wire AB. Power source: key. Ammeter, voltmeter, jockey. And these are seen in this experimental setup we have here. Power source, key, the ammeter, the voltmeter, the jockey, the resistance wire, so to speak. Now let's see the procedures. Place the sliding contact C on the resistance wire. You can see how we place it on the resistance wire. Yes. Record the value of X as seen above. Record the distance between AC. The distance between AC is value of X. And switch the circuit on. Once you close down this circuit, once you close it down, it is called a closed circuit. That means I have switched it on. Its current will start flowing. Okay, using the voltmeter, measure the potential difference V across AC. Wow. So once I close out this circuit, I will take the measurements or the reading I see in this voltmeter. I will also take the measurement I see in this ammeter, and that is what you see in the second one. Using the ammeter, measure the current I in the wire. Record the value I. Okay. Take the sliding contact away from the wire AB. That is, remove this jockey out. Remove it from this resistance wire. And switch off the circuit. This circuit, I will now switch it off by opening it. Calculate the resistance R of the section AC of the wire using the equation R equals to V over I and record R. So from B and C, we got our V and I. So we will say our R is equal to V over I. That is what we do. So that one is easy. Repeat steps A to D with the sliding contacts at distances of 0.3 meters, 0.5 meters, 0.7 meters, 0.9 meters from A. Wow. So what you do here is, after taking the one of the distance AC to be what? 0.3 meter. To be 0.3 meter. All you need to do, you take the one of 0.5 meter, you take the one of 0.7, 0.9. So after taking the one of 0.1, from here to here 0.1, from here to here you shift it again to 0.3, you shift this jog again to 0.5, to 0.7, to 0.9, and check the values you'll be getting from your ammeter and from your voltmeter, so that you can get your value of what R. With that, you will be able to know whether the values you are getting, whether they are in increasing order, whether they are directly related, or whether they are inversely related. And that is the essence of this practical. Plot a graph of R against X. That is where you will check whether it's directly or inversely related. Within the limits of experimental accuracy, state your conclusion. That is for you to say whether they are directly related or inversely related. Using your graph, determine a value for the resistance R when the length X is this. So we'll be getting this from the graph. Okay, remember what I said. The essence of this experiment is for us to learn how we can conduct it without touching any apparatus. Remember that the power source is 3 volts, right? Okay. Now, the internal resistance was given to be 1.0 watt ohm. That is about the internal watt resistance. Yes. The EMF is 3.0 volts. What other thing that they gave us? Okay. Now, the type of wire we use is what we call constantan wire. Constantan wire. I'm just telling you parameters we need for us to what? Answer this without touching apparatus. Now, this constantan wire we use here, the diameter of it was checked using micrometer screw gauge, and when we check it, we got the diameter to be equal to 0.37 millimeter. Wow. Then we also check the resistivity of a constantan wire. Resistivity of a constantan wire is given this way to be equal to 4.9 times 10 raised to power minus 7 ohm meter. Wow. These are the parameters we need for this experiment. Okay. We need to recall these formulas, that resistance is equals to resistivity times length all over area. We need to recall this formula. We need to also recall that I is equals to E all over R plus R. We need to know that. We need to also know that V is equals to IR. That is from Ohm's law. All these formulas are not new to us because we have seen them in the introduction part of the topic electricity in physics, theory aspect of it. I've been seeing them. Now, how do we make use of them? First and foremost, we use this formula. We use this formula to get our resistance. Yes, this length now, this length L will now be that distance X we are talking about, that distance X. That is what we call this length. So we say distance X. Are you getting it? So what do? Let's first and foremost get this value. Once we get this resistivity over area, we can get our various value for resistance when we talk about different distances given to us. Oh yeah. We now say let K be equals to what? Resistivity over A. What is the meaning of resistivity? We have it. Okay, our A, because the constantan wire, the area of constantan wire, when you get a constantan wire, it looks as if it is in a circular form. That the tip of it looks as if it's in a circular form. We say the formula will be what? Pi r square. But we got the r in terms of what? Diameter. The diameter of it is 0.37 millimeter. That is with what? Micrometer screw gauge. So diameter divided by 2 is radius. So we will clean this and say diameter square all over 2 square 4. So area will be equal to pi d square over 4. So how do we now compute it? We now say pi times 0.37. Pi times 0.37. Let's write it down. A equals to pi times 0.37. Now this 0.37 is a millimeter. To change it to meter, we say times 10 raised to power minus 3 all over 4. You square here. So when you do this, you'll be having, let's check, shift pi times bracket 0.37 times 10 raised to power minus 3 all squared divided by 4. We'll be having it to be 1.075 times 10 raised to power minus 7 meter squared. That is the area. So we now say that this will be equals to what? 4.9 times 10 raised to power minus 7 all over 1.075 times 10 raised to power minus 7. So what should that give us? We will now be having it to be equals to 4.9 times 10 raised power minus 7 divided by bracket 1.075 times 10 raised power minus 7. We have it to be 4.558. That is a constant. Yes, that is a constant. We have it to be in the home per watt meter, home per meter. That is the units of this constant I got here. Home per meter. Yes. So with that, my R will be equals to, I will now say this value which is your K times the first value, bracket 4.558. My R equals to this value of what? K times the X. So when we have it, we say 0.1 times 0.1 times 4.55 watts 8. That will be giving you 0.4558. Then for at 0.3 meter, for the one of 0.3 meter, you say 0.3 times, okay, this is ohms. Okay, all of them are in ohms, times 4.558. That will be giving us 1.367. So this is approximately 1.37, and this is approximately 0.4 watt 6. Then check again. When S is 0.5 times 4.558, that will be giving you 2.28 watts ohms. We do the one of 0.7 times 4.558, that will be giving you 3.19. Then do the one of 0.7. 0.9 times 4.558, that will be giving us 4.10. All are in ohms. We have got resistance, that is the external resistance. How can I get my current? Using the formula I equals to E over R plus this. The first I will be equals to, I will now say 3, which is our EMF, all over the first R plus 1. This one is our internal resistance, which we say is 1. So we'll be saying now 3 all over 3. Let me put it here. I is equal to 3 all over the first value, 0.46 plus 1 internal resistance. Are you getting it? So after that, we change this to 1.37. After that, you get, okay, let's check it out. 3 divided by 0.46 plus 1 will give you 1.46. 1.46. That will be giving you 2.05 amperes. Then we change here to 1.37. 1.37 plus 1 will 2.37. 3 divided by 2.37. We'll be having 1.27. 1.27. Then we check again. 2.28 plus 1, that is 3.28. 3 divided by 3.28, that will be 0.91. Then 3.19 plus 1, 4.19. 3 divided by 4.19, 0.72. Then 4.10 plus 1, that is 5.10. 3 divided by 5.10, that is 0.59. This one is in amperes. Okay? So, after we got this, what will be the value for your voltage? Remember that voltage is equal to I times what? R. And our I, we have gotten, and our R, we have gotten it. So we multiply this times this. 2.05 times 0.46. That will be giving you 0.94. 1.27 times 1.37. That will be giving you 1.74. 2.28 times 0.91. That will be giving you 2.07. 3.19 times 0.72. That will be giving you 2.30. 4.10 times 0.59. That will be giving me 2.42. Everything is in volts. So we have seen now that with use of formulas and our background knowledge of the experiment, we can get the value of what? R, I, and what? V. We can get the values of what? R, I, and V. Then if they ask you using your graph, determine a value for the resistor R when the length X is this. You can also get it without your graph, because you know that this over this is what gave us 4.558. That means if they ask us to get resistor R when the length is this, all we need to do here is we say our R is equal to this over this is 4.558. We say 4.558 times our X 0.7. You just say 4.558 times 0.7. That will be giving you 3.2 ohms. So you can also get it from there. But let's see how to go about with plotting of the graphs and explaining all these questions asked here. Let's see from the graph how they are related, the resistance and the length of the wire, how they are related. Okay, let's see the graph aspect. Okay, so these are the table of values we have. These are the values we got from this experiment: our X, our V, our I, and our R. I want to see how we can plot them now on the graph. Remember that this is not a graph sheet. It's just a sketch of graph. You understand? It's just a sketch of a graph sheet that will help us to see the nature or how the slope will look like. Remember, in our videos on our channel, I've posted a lot of videos on how to plot graphs and rules concerning plotting of graphs. First and foremost, write the title of your graph. A graph of R in ohm against X in meter. Once you write the title of your graph, don't forget to write your date. Date equals to I will write my own. Okay, Don't forget to do that. Then next thing is the instruction is plot a graph of r against x. They did not specify if we are starting from origin or if we are not starting from origin. And so if they did not specify, plot the one you can plot. You understand? Because they did not specify. And so because they did not specify, I decided to plot my own from the origin. I put my Cartesian axis here, and I put my Cartesian axis here, and this becomes 0, what? 0. That means I'm starting from origin. So this is my R own, the vertical axis own. I will say R is a what? Ohms. And what? X is a what? Meter. Wow. I've gotten that. For R, I decide to write by 0.5, 0.51, 1.52, 2.53, 3.54. Okay, so 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. Okay, then for my X value, I decided to go by 0.2 because the least is 0.1 and maximum is 0.9. So 0.20, 0.40, 0.60, 0.80, 1.0. Wow. So let's plot 0.1 against 0.46. 0.46 should be around here, and 0.1. So we can put it somewhere here. Then the next is for us to put 0.3 and 1.37. 1.37. This is 1 and this is 1.5. This is 1.25. So 1.37 should be somewhere here. Remember that this is just a sketch of graph sheet. Okay. We have 0.3 here. Then the next one, 0.5 and 2.28. 0.5 here, 2.28, 2.25 here. So the next one, 0.7 and 3.19. 0.7 and 3.19. Somewhere here. The next one, 0.9 and what? 4. What? 10. 4.10. Somewhere what? Here. Taking our line of best fit. Now, looking at this line of best fit, you will notice that there is a point I circled. Where or what is this point representing? That is the mean of the x-axis, s values and r values. That is their mean. That means add up this 0.1 plus 0.3 plus 0.5 plus 0.7 plus 0.9 divided by 5. The mean of what? Mean of x will be equals to, if you add all this divided by 5, you will have 0.5. Then if you add all this divided by 5, you will be having that mean of r will be equal to 2.28. This is in meter and this is in ohms. Okay, so remember that your line of best fit must pass through the mean of what? Mean of the x and mean of the r. That is what will help you to know actual direction this line of best fit should pass. Remember, this is one of the points. This is the only one point fell out of this line. Only one point fell out of this line. Just only one point. So what we need to do now is that we'll take our what? Our slope. Use your ruler to rule it so that to be straight. Then connect it to this. So this becomes change in x equals to, here is what? Where the vertical and horizontal axis meet. So you take it out, 0.8 minus, here is where, or the lower value of it, which is about 0.3, is about middle of it, 0.3. Then here, change in r, which is equals to, here is in between 3.5 and 4, so you have 3.75 minus, here is 1.5. Remember, our slope becomes change in r all over change in x. Change in r, 3.75 minus 1.5, that will be giving you 2.25 all over 0.8 minus 0.3, that will be giving you 0.5. So 2.25 over 0.5. The unit of this is ohm and unit of this is a meter. So that will be giving you slope to be equal to 4.5 ohm per meter. Remember, your units must be attached to what you get. So from this, our experiment, you notice that this gave us a straight line. So if you want to make your conclusion, say from the experimental results and from the graph, it is realized that as the values of resistance increases, the value of length also increases, or as the value of the length x increases, the value of resistance increases. That is why we are getting a positive slope. So they are directly what? Related. They are very much directly related. Now they ask us to get the value of r when x is equal to 0.7. X 0.7. Look at 0.7 in between 0.6 and 0.8. You trace it what? Up. Use your ruler to trace it up. So when you trace it up, you see the value. The value is more than 3. So about 3.2. Is about 3.2. Yes. So when x is equal to 0.7 meter, r is about 3.2 meter, 3.2 ohm. Yes, 3.2 ohms. So that is about that. Remember, every experiment you just finish doing, try to write your precaution taken. For instance, in this experiment, we use ammeter and we use voltmeter. So you talk about error due to parallax was avoided while taking my reading from ammeter and voltmeter. You get? And zero error was also avoided by taking my reading from 0, ensuring that my reading starts from 0. You understand? So you try to write your precautions too. It has its own marks. Thank you for watching today's video. See you in our next video.